Friedel-Crafts acylation reaction. When benzene or a substituted benzene is treated with acid chloride in the presence of anhydrous AlCl3 or FeCl3, it gives the corresponding ketone. This reaction is called Friedel-Crafts acylation reaction. So the catalyst you are using is anhydrous AlCl3, or you can use FeCl3 also, but better results with AlCl3. Both these are Lewis acids, that is, they are electron deficient. Now you can represent the Friedel-Crafts reaction like this. On the benzene ring, you are substituting R C double bond O Cl like this, and you will be getting OR plus HCl. You can use aryl group also here. Now let us use benzene and acetyl chloride, that is CH3 C double bond O Cl, or ethanoyl chloride, in the presence of, it's all in the presence of anhydrous AlCl3. Anhydrous AlCl3. You're getting C double bond O CH3 plus HCl. This is acetophenone. Now you can get acetophenone if you are using acetic anhydride in the place of acid chloride, CH3 C double bond O CH3 C double bond O, this also, but the byproduct will be a carboxylic acid. So this is an electrophilic substitution reaction. Electrophilic substitution reaction. So here you can see that it is C double bond O CH3 which is getting substituted. A hydrogen is getting replaced. A hydrogen on the benzene ring is getting substituted by this group, that is C double bond O CH3. Now this is called the acyl group. If we look at the mechanism of Friedel-Crafts reaction, you can see the mechanism can be divided into 3 steps. First one is the generation of an electrophile. An electrophile. An electrophile, as you know, is an electron deficient species. It is coming in search of electrons. So how are we getting this electrophile? We have the reagent CH3 C double bond O Cl here, plus AlCl3, our catalyst. Now chlorine is electronegative. It will pull the shared pair of electrons towards itself. And this chloride ion will be accepted by AlCl3 because it is electron deficient. And as a result, you will be getting AlCl4 minus and CH3C double bond O. There will be a plus charge on this. So that is your electrophile. This acyl group is your electrophile. So that is the first step. Second one is substitution of the electrophile on the benzene ring. So it is substituting a hydrogen on the benzene ring. The benzene ring can be, you can represent it like this. There is a hydrogen here. Let it be there. Now when the electrophile approaches, C double bond O CH3 is coming. This is electrophile. This pair of electrons, that is the double bond, shifts here. The electrons will shift here, and as a result the electron density here will increase, and this electrophile will get attached at this carbon here, and you will be getting this hydrogen is here. C double bond O CH3 has got attached here, but this bond is no longer there because those electrons had shifted to this place, and you will have a positive charge on this carbon. These bonds are there as before. In the next resonance structure, we can see this carbon is now electron deficient. It will pull these electrons towards itself, and that will result in C double bond O CH3. The bond is formed there, but this carbon is now electron deficient. What will happen? This carbon will start pulling these electrons towards itself, and H is here, C double bond O CH3 is here, this bond is here, and here you have a double bond, but this carbon here is having a positive charge. Where will it get electrons from? This bond breaks and hydrogen will leave as H plus ion, and this bond is breaking and hydrogen will leave as hydrogen ions, and the electrons will come to this carbon. So as a result, a double bond here, double bond here, double bond here. Hydrogen is gone as hydrogen ion, and C double bond O CH3 is here. You have your product acetophenone plus H plus ion. That H plus ion from the hydrogen which was there on the benzene ring. Now the next step is the regeneration of the catalyst. You need to get your catalyst back after the reaction. So we have our catalyst was anhydrous AlCl3, but now it is in the form of AlCl4 minus. So AlCl4 minus plus H plus will give you AlCl3 plus HCl. So this is your catalyst, and now you have got it back. So these are the steps involved in the mechanism of Friedel-Crafts acylation reaction. First one is the generation of, first of all remember that this is an electrophilic substitution reaction. Friedel-Crafts reaction is electrophilic substitution reaction. The group getting substituted is the acyl group, that is CH3C double bond O, that is replacing a hydrogen or substituting a hydrogen on the benzene ring. And the steps of the mechanism are, first one, generation of an electrophile. An electrophile is generated. That is from CH3C double bond O Cl plus AlCl3 is giving you the electrophile and AlCl4 minus. Electrophile is the acyl group. Then substitution of the electrophile on the benzene ring. From the benzene ring, it is replacing a hydrogen atom on the benzene ring, and it is getting substituted there. That is how you are getting acetophenone as the product when you're using benzene and acetyl chloride or ethanoyl chloride. Then regeneration of the catalyst. The catalyst AlCl3 is obtained back. When AlCl4 minus and H plus ions are reacting, you are getting AlCl3, the catalyst, back. We can just summarize it as, when benzene or a substituted benzene is treated with acid chloride in the presence of anhydrous AlCl3 or FeCl3, it gives the corresponding ketone. This reaction is called Friedel-Crafts acylation reaction. Anhydrous AlCl3 is the catalyst used. It is a Lewis acid. It is electron deficient. You can convert benzene to ketone or acetophenone using this reaction.